Hi there, and thank you for your questions. This first question is from page 681 in the new 6th edition textbook, and it is 47B. And for this question, it says, determine what is wrong with the name of this alkane. So for this alkane, they are calling it 2-ethylpentane. Now for 2-ethylpentane, where they see that is that they see the carbon chain as right here. So if I just grab my pen, they're saying that this is carbon 1, this is carbon 2, this is carbon 3, 4, and 5. And then this H2C CH3 is the ethyl group. And it would be coming off the second carbon. But in organic chemistry, it's very much all in how you look at the structural formula. So what I'm going to do is erase this back here. And when you look at this, you first have to identify the longest carbon chain. And the longest carbon chain is actually starting here at this carbon and then working your way around this way. So this actually becomes carbon 1, this becomes carbon 2, 3, 4, 5, 6. So the longest carbon chain that you can make is 6 carbons, and you are allowed to bend the carbon chain, but as long as the carbon chain is the longest, that's what you want to go for. So for this alkane, we're looking at a 6 carbon chain, which makes this a hexane rather than a pentane. And then this becomes the alkyl group that comes off of that. And the alkyl group for H3C is methyl. And that's coming off of carbon 3. So the actual name for this compound is 3-methylhexane. And the big takeaway from this is that when you are looking for the longest carbon chain, you are allowed to bend the chain. It doesn't have to be a straight chain, it just has to be the chain with the most carbons in it. So this one is question 47A, and again they're giving the wrong name for this compound, and we need to determine what the correct name is. And the question was, would a substituent come off of the first carbon in a chain like this? Now very much like the last question, when you have a substituent looking like it's coming off of this one here, looking like it's coming off the first carbon, remember that we're trying to create the longest chain, and you can bend the chain. So this one is actually just a long chain of carbons. So starting here, we can bend it all the way around. And so we have 1, 2, 3, 4. That's a 5 carbon chain. So that means it's a pentane. And because there are no groups coming off of it, we just say N-pentane. So again, just remember that you can bend the chains. You just want to create the longest chain, and if that includes bending, that includes bending. In your next question, you were looking at page 653, part 3 of the naming alkanes. So let me grab my pointer here. So we're looking at this part here. And in this part, we're looking at this compound here, and you can see that it has a chain of 6 carbons here, but if you wanted to try and bend it to make the longest one, you'd have 1, 2, 3, 4, 5, 6. So it really doesn't matter if you keep it straight or bend it, it's going to be the same name. And even when you do that, CH2, CH3, CH3, CH2, same group. So in this case of ethyls, so we still have the same components coming off, the same groups coming off. So no matter which way you count the carbons or which way you make the chain, you're still going to get 3-ethyl hexane, because even if I bend it, 1, 2, there's my third carbon with the ethyl group coming off of it, or 1, 2, 3 with ethyl coming off of it. So whether you bend it or you keep it straight, you're still going to come up with the same name. And for this one, same sort of thing. You can count your carbons across, or you can start here and bend it, and you'll still have your 7 carbons. So if I start here at carbon 1, then I'm going to bend the chain, and this one right here is a methyl, or this one's a methyl. So depending on which way you go, you still have a methyl coming off of this second carbon. So we have, I'm going to pretend that I'm going to go as if I'm creating a bended chain, and then this one is your ethyl. Now, and the ethyl's coming off of the 4th carbon, and your methyl's coming off of the 2nd carbon. When you go to write this, we do have 7, so that's going to be a heptane. And then the way you write your alkyl groups or your substituents is not by the order in which they occur on the compound. It's always going to be alphabetical order. So E comes before M, so we're going to have 4 ethyl, like that, and then 2 methyl, and then right into heptane. Now, as to what they're saying in the brackets, right here, if 2 substituents occur at equal distance from each end, go to the next substituent to determine from which end to start numbering. Now, they didn't give an example here to explain what that means, so I'm going to give you an example to show you what that means. So here I am on page 654 of your textbook, and I'm looking at Skill Builder 18.6. So this is an example that illustrates what was in the brackets. First of all, let's first find out what type of hexane, this alkane, sorry, this is. It is an alkane because we have all single bonds. And in terms of numbering my carbons, I can go straight across, and I have 1, 2, 3, 4, 5, 6 carbons. I can try something bendy like this, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. It looks like no matter where I start in terms of these carbons, I'm still going to get 6. So just to make it easy for myself, I'm going to choose the straight carbon chain here and not bend it. So if you have the choice where you have equal number of carbons, stick with the straight across chain. It just makes life easier. So I'm going to go ahead and number those carbons. So I have carbon 1. Oh, I think I'm going to put it on top. There we go. 1, 2, 3, 4, 5, 6. So I have 6 carbons. So that is going to give me a hexane. And then my substituents are all CH3s, which means that they're all methyl groups. So there are 3 of them, so I can call that trimethyl hexane. Now the last piece of this question is to figure out the location of these methyls so that I can put that here. Now you always want to count from the end that's closest to your first functional group or your first substituent group. So looking at this, I have CH3 coming from this end on my second carbon, and then I have another CH3 coming from this end on my second carbon. So that's the substituents that are equal distance from the ends. So because they're both one in, that doesn't give you any idea of which end to count on. So that's why you move to the second substituent. You want to count from the end where the substituents are closest. So this CH3, if we count from this end, comes off of carbon 4, but if we count from this end, it comes off of carbon 1, 2, 3. So really, I should have started my count of carbons from this end because the majority of the substituents are closest to this end. So just a recap, I have a hexane, I have 3 methyls for a trimethyl. My first substituents are equidistant from each end. So this one is on the second carbon from this end, this one is on the second carbon from this end. So if I'm going to decide which end to start my count, it's dependent on this next substituent group. And this next substituent group we find out is closer to the right side and further away from the left side. So I should have counted from my right side. So this is going to be carbon 1, 2, 3, 4, 5, 6. And now I can say that I have this methyl is coming off of carbon 2. And then this one is coming off of carbon 3. And then this one is coming off of carbon 5. And there you go. So this is an example where you have 2 substituents that are equidistant from each end. So in order to decide which end to count from, you're going to go to the next substituent and choose the end that's closest to that next one. And lastly, on page 653, you ask in example 18.4, 18.5, they have the ethyl, which is right here, CH2, CH3, listed with the CH2, the CH3 branching from the CH2, and then we have it here where it's listed as a chain. Does it make a difference? Is your question, and the answer is no. It doesn't make any difference whether they are stacked on top or whether they're written as a chain. The challenge for you is just that you're able to recognize both as ethyls. So I hope this video helps. I can see that you are totally working through the problems and you're now just polishing up the little nuances that aren't always that clear. So great job, and keep asking your questions. Bye for now.